Okay, so we're continuing here. It's we have a triangle, PRQ. The lengths of sides, for triangle PRQ are 10, 24, and 26. I actually changed the numbers because the numbers I had before actually didn't make a right triangle, but now they do. So 10, 24, and 26. If angle Q is 90 degrees, find the value of the three primary trig functions for the smallest angle. So this is actually a pretty simple question, but what we're going to do here is I'm going to draw out my triangle. It's got sides 10, 24, and 26. Okay, I know that the longest side is going to be the hypotenuse. I know it's a right triangle because one of the angles is 90 degrees up here. And so that's angle Q, by the way. And then this is going to be angle P, and this is angle R. It doesn't really matter which one is which because it doesn't say. Now, the smallest angle is going to be R. R is the smallest. And now if I want to find the value of the three primary trig functions, primary trig functions are sine of angle R, cosine of angle R, and tangent of angle R. All right? And so remember, the primary ones are sine, cosine, and tangent. The reciprocal ones would be secant, or cosecant, secant, and cotangent. But we'll look just only at the primary ones for this question. And so this question is almost done right now because I have a triangle. It's 10, 24, 26, 10, 24, 26. The smallest angle in a right triangle, by the way, is always opposite of the smallest side. Okay, and so you will know that R is going to be the smallest because it's opposite of angle, or of side 10. This is going to be the second smallest, and this one will be the largest angle. The right angle is always the largest in a right triangle. Now, if I want to figure out the sine of R, the sine I just know is opposite over hypotenuse. So it's 10 over 26. And there. That's what the sine of R is. The cosine of R is adjacent over hypotenuse. Adjacent over hypotenuse would be 24 over 26. And the tangent of R would be opposite over adjacent, and so it would be 10 over 24. And there, that question is now complete. So all I needed to do was set up the triangle, and be able to read this and set up a nice triangle. Then I use the opposite, or the SOHCAHTOA definitions to figure out what the sine, cosine, and tangent. If you notice that in these questions, sometimes you use opposite over adjacent, opposite over hypotenuse, adjacent over hypotenuse. You use the opposite, adjacent, hypotenuse ones. Then in some of the questions, like the ones that we did just a little while ago, you want to use the x over y, or the x and y definitions for sine, cosine, and tangent. You should be aware that they're both valid, and some are more convenient than others depending on what the question is asking. So there's that. And now for the final one. In the following figure, well, let me get this here. In the following figure, if the coordinates of point P are the -2 over the square root of 6, comma, square root of 2 square root of 6, find the value of the cosine of theta plus pi. This question is also actually pretty easy to solve if you think of it in a particular way. So in my figure here, I notice that theta is this angle right here, from here to here. Okay? Now if I add pi to it, pi is a half a rotation. And so my new angle would be right here. And so this would be pi, or theta plus pi. So the angle theta plus pi is this angle. Okay? And I know that the two coordinates here for this right there, if I know that these two coordinates are negative square root of 2 over 6, negative, this should also be negative here, negative 2 over the square root of 6, comma, negative square root of 2 over 6, square root of 6. Both, I know that these 2 points are right here. I hopefully there should be a negative in the question. I don't know if there was on the sample test. But make sure you change this to a negative. So now I know that because I've added pi, there's a bit of a symmetry here. I know that this point is now up here. And so the actual points here and here, they're actually the same exact points. Negative, but they're both positive. So one is 2 square root of 6, and the other one is square root of 2 square root of 6. Okay? And so that basically tells me that this distance here, this length here is, since this is a y coordinate, that tells me this distance. Since this is an x coordinate, that tells me this distance. So I'm going to take this triangle out. And I need to find the radius value right there. And I know that this is the square root of 2 over 6, square root of 6, sorry. And this is 2 square root of 6. Nope. And so if I want to find the radius, I say that the radius squared is equal to this squared, or square root of 2 over square root of 6 squared, plus 2 square root of 6 squared. And now this is going to be the radius here. And since I'm trying to find the cosine of this angle here, I'm going to need the cosine of theta plus pi is equal to the x-coordinate divided by the radius. So sometimes the radius is not equal to 1, and we're not sure. Maybe the radius will be equal to 1, but we need to see what it is here. I do know that the x-coordinate is 2 square root of 6. The x-coordinate of this angle, because I'm trying to find cosine of theta plus pi. So theta plus pi is here. So I need to go get the x-coordinate, put it there, and I need to get the radius and put it here. But the radius is this distance, and I need to find it using this triangle. And so I do the Pythagorean theorem. This math isn't as bad as it looks, because square and the square root of 2 squared is just 2, and the square root of 6 squared is just 6, plus 4, 2 squared is 2, sorry, 2 squared is 4, and the square root of 6 squared is 6. Oh, look at this. It actually is going to equal 6 over 6. So the radius squared here is 6 over 6, or 1. And so the radius, if I take the square root, 6 divided by 6 is equal to 1. Oops, I've kind of lost you here. Sorry. This is what I've been doing. I squared each of these and wrote them here. I think you saw that. Then 2 sixths plus 4 sixths is equal to 6 sixths. 6 sixths is 1. The square root of both of these is, so the radius is 1. And so I'll put a 1 right there. And so this is the value of cosine of theta plus pi. So again, I started with theta. I added pi. Due to the fact that there's a bit of a symmetry here, when I add pi, this flips up to here. So then both of these points, the x points here, are the same, because if I flip this up to here, then this distance is the same as that distance, and then this distance is the same as, oops, sorry, I kind of lost you again there. These two distances are the same, and these two distances are the same. And so, like I said, because I've started with theta, and I've added pi, these go up to here. Now we know that the points are the same value, but now they're both positive. And so now what I do is I use these two values in this to try and find the radius. The radius I find is actually equal to 1 in this example. And so the cosine of theta plus pi is equal to the x-coordinate divided by the radius. And the x-coordinate I know already is 2 squared root of 6, and the radius is 1. So these are some of the more complex questions that you'll be doing with us here.